All right, so today our big topic is mixed factoring review. So we're looking at all of the core variations of factoring that you learned in the Algebra 1 year and reviewed throughout the geometry year as well. So first thing to always look for, the first rule of factoring is look for a GCF. Divide out your greatest common factor. So looking at this very first problem, when I look at my two terms, I'm looking at the number that they share in common. They're both divisible by 8, and they both have an x. So I'm going to divide out 8x from both of the terms. So if I divide 8x squared by 8x, I'm left with an x. And if I divide a negative 40x by 8x, I'm left with just minus 5, just like that. You should always be looking at it backwards. So if you then distribute that 8x back over the x, you're back to 8x squared, and the 8x times negative 5 gets you back to negative 40x. So you know that you have factored it correctly. Okay, next one, looking at the two terms. For the numbers, we see that they are both divisible by 20, and they both also share 1x. So we can divide out that GCF of 20x. So if I divide 60x to the fourth by 20x, I'm left with 3x to the third power. If I divide that negative 20x by 20x, minus 1. Double check it, distribute back. 20x times 3x to the third restores us back to 60x to the fourth, and 20x times negative 1 is negative 20x. So we are good. So for any type of factoring, that is the first thing to look for a GCF. Okay, next pattern to look at is a difference of two squares. So we see a perfect square minus a perfect square. So two terms, they're both perfect squares, and we see subtraction joining them. It breaks into, in parentheses, x minus 7 times, in parentheses, x plus 7. We have to really remind ourselves also that there is no way to factor a sum of two squares. There is no sum of two squares, only a difference of two squares. So when I look at this problem, I see x to the second power minus 49. Well, I know that this is just saying x times itself, x times x, and 49 is 7 to the second power, right? 7 squared. So now when I break this up into the two factors, I can write it as x minus 7, closing my parentheses like that, times x plus 7, close the other set just like that. Let's say that I wanted to make sure I could always multiply back. So if I FOILed it back, my first x times x would be x squared. My outer would be plus 7x. The inner would be minus 7x. That's why there's no linear term in the middle, right? No x term in the middle. And then negative 7 times positive 7, we're back to negative 49. So we're good. Fully factored. Okay, next one here, I see again, I have two terms. They are both perfect squares. So right here, I see that that is 6x as a quantity squared. And then 1 is just 1 squared. So now when I break it up into the factors, I'd say that's 6x minus 1 times 6x plus 1. And again, when I double check it, the 6x times 6x is that 36x squared. The outer and the inner are opposites. That's why we don't have a linear term in the middle. And that negative 1 times positive 1 is that negative 1 right here. So we are good. If you write these factors in opposite order, if you put this one before this one, no problem. It's the same thing. All right, problem 5. So again, I see two terms. They are both perfect squares. Here I see that this is 5x as a quantity squared, and then 8 squared. So then when I write it as my factors, I'd say 5x minus 8, close parentheses, times 5x plus 8, close that second set of parentheses. That is fully factored. Again, getting that good habit. Foil it back out in your head, right? There's that first, gets you back to the 25x squared. The outer and the inner are opposites. Again, that's why there's no linear term in the middle, and that negative 8 and positive 8 multiply to that negative 64. Okay, this last variation, I have x to the 4th power minus 625. Well, x to the 4th power is still a perfect square, right? It's x to the 2nd power squared. And 625 is 25 squared. So I still have a difference of two squares pattern. So I can break it into x squared minus 25 times x squared plus 25. But when I stare at this and I think, well, am I done? Well, no, because over here, this package is still a difference of two squares. Remember, there is no sum of two squares. I can't break this down any further. But this one I can, because I can see that this is really x squared, and this is 5 squared. So it becomes x minus 5 times x plus 5 times x squared plus 25, right? There is no sum of two squares. I often get the question, can't I factor this? Let me use a pencil, right? Can't you factor this, Miss Crystal? Can't you make this x plus 5 times x plus 5? So watch what happens when I multiply that out. My first is x squared. My outer is 5x, my inner is 5x, and my last is 25. I would have a 10x in the middle, which I do not have, right? I do not have that here. So that verifies for me that this is not going to factor. There is no sum of two squares, only a difference of two squares. This is fully factored, and I can write these separate factors in any order I want. I think of this variation as a difference of two squares times 2, because we had to break it into this structure first, and then we did it again. All right, next skill, looking at the basic quadratic trinomials. So here I'm saying it's basic because that leading coefficient a right here is 1. Okay, quadratic because it's x to the 2nd power. That's your highest degree. That's what makes it quadratic. And trinomial because we have 3 terms. Now when we are doing this, even if we don't need to draw this cross, we need to know what it is we're looking for when we're factoring it. So we need to really see what the a, b, and c values are. A is the coefficient on the quadratic term, b is the coefficient on the linear term, and c is the constant. So we're thinking of what is the product, which is a times c, right? That's the product, just a fancy way of saying multiply. And then what's the sum? The sum is the b. Right, just makes us add. So when I look at this problem, I see that I have 3 terms. The highest degree is x to the 2nd, right? So that tells me that it's quadratic, right? That leading coefficient is 1. So even if I don't draw it out this way, this is really what I'm thinking. What is the product? What is the sum? 1 times negative 36 is negative 36. My sum is negative 5. So what are 2 numbers that multiply to a negative 36 that add to a negative 5? right? It has to be negative 9 times 4. Stare at that. Do those multiply back to negative 36, right? They do. And do those add to negative 5? They do. So we write it as x minus 9, close parentheses, times x plus 4, close that second set. And if you wanted to double check, right, FOIL it out. There's the first, that's the x squared, the outer plus 4x, the inner minus 9x, combines to make that negative 5x in the middle, and then the last, that's our negative 36 right there. We are good. Okay, this next one, I see that there's a negative out in front, right? This is really not a basic quadratic trinomial until I divide out that GCF first. So whenever there's a negative out in front, a negative 1 out in front, you want to divide it out first. And when you divide out that negative 1, every term flips to the opposite sign. So now that I have that negative 1 divided out, now I have a basic quadratic trinomial left behind. And again, even if I don't write this out, it's certainly what I'm thinking. What are the two numbers that multiply to negative 56 that add to 1? Okay, I know that when it's 1, those two numbers need to be consecutive, but they're going to be opposites. So I know it needs to be 8 times 7, but which one is the minus? Right, it must be the 7 that's the minus in order for it to add to 1. So now I have negative 1, that has to go first. And then I have x plus 8, right? I'm putting that in parentheses, and then same with the x minus 7. Now these two binomials can go in either order, but that negative 1 does have to go first when it's fully factored. All right, let's flip a page, go on to the next skill. All right, so the next variation is looking at grouping. So if you look at this structure, you see that we now have a polynomial that has 4 terms to it. And this is the only method that we can use to factor, is to factor by grouping. So again, it has many terms. That's why we say polynomial, specifically 4. 4 terms, right? I see something cubic, quadratic, linear, and constant. So right here, I've done it. I've actually kind of put it in this structure so that I'm almost factored. And I did this intentionally so you could see about structure and how we could reshuffle, we could group it in a factorable way. So here I'm looking at x squared times this package of x plus 4 minus 5 times that same package of x plus 4. So since these two packages match, we can regroup it. We can rearrange it as x squared minus 5, right, in parentheses, times x plus 4. And that's really it. That is fully factored. That is all we need to do. But I really want to go over why, because I often get the question, why are you not squaring the x plus 4? So I want you to think about this. I'm going to write this down. Think about why these structures are the same. Okay, so let's say that I look at how the problem started. So x squared times the package of x plus 4 minus 5 times that same package. So here, that was the first way of viewing it, versus regrouping it into an equivalent structure, which is ultimately what we want. So if I look at this first part of the problem, right, how it started, I would have to distribute that x squared over that binomial, that package of x plus 4. And then over here, if I was to FOIL that out, I can see that that first and the outer would be the same multiplication. When I distribute that -5 over the x and the plus 4, that's the same thing as when I multiply the inner and the last when I'm FOILing it out. So they would be the exact same thing in standard form. All right, so in standard form, we would have x to the third power plus 4x squared minus 5x minus 20. Right, so they would look the same way if we multiplied it out by distributing twice or FOILing it out, right? They are equivalent structures. We want to see it factored. All right, next example here. Now I'm seeing it in standard form. So the way that we factor this way is we group the first two and then we group the last two. And we look for a GCF. So over here, I see that they share in common an x to the second power, leaving behind an x plus 3. And then over here, they share a -7, leaving behind an x plus 3. So again, these match. So we can regroup it, rearrange it as x squared minus 7 in parentheses times x plus 3, right? Closing that second set of parentheses. And that is fully factored. That's what we want to see. All right, next up, looking at more complicated quadratic trinomials. So again, paying close attention to those coefficients, right? Quadratic, linear, constant. And here we're saying it's more complicated when that leading coefficient is no longer 1. So we really want you to be able to factor using the guess and check method, but I'm going to show you two different methods, and you can pick what works best for you. So guess and check, I'd start by opening parentheses. I'm going to write that this is guess and check. Okay, so if I look at that 3x to the second power, to get there I must have a 3x and an x in those first two positions. Now to get to that -7, I must have a 1 and a 7, and one of those must be negative. So if I think about what has to go where, so let me do this lightly with pencil. So imagine that I put the 7 here and the 1 here to start. The outer would be 3x and the inner would be 7x. Even if one of those is positive and one is negative, it's not going to get me that -20x that's in the middle. So let me switch position and try it the other way. What if there's a 1 here and a 7 here? Okay, the outer would be 21x, the inner would be 1x. So I can see that if I put the minus here, I would have -21x, and the plus here, plus 1x, that would get me that -20x in the middle. So I'm done. I have done my job. It is fully factored. Okay, the other way that you could approach it, though, is using a grouping method. So let me walk you through that in case this doesn't feel intuitive to you. So let me rewrite the problem. Okay, so the way that I would start is I would make that same kind of cross where I'm looking at the A times C and the B, so the product and the sum. So here I'm going to use a grouping technique. All right, so 3 times -7 is -21, and then the sum has to be -20. So I'm looking for two numbers that multiply to negative 21 that add to negative 20. So it has to be negative 21 and 1. So what you're doing then next is you're picturing these two terms with an x, replacing that linear term right here. So now when I rewrite this, I have 3x squared minus 21x plus 1x, or just x, and then minus 7. Right? These two can combine and get me back to that negative 20x in the middle. And now I can keep factoring by grouping the first two and the second two. So the first two, if I look for a GCF, I have a 3x, leaving behind an x minus 7. Over here, nothing to divide out except for a 1. So plus 1, leaving behind an x minus 7. These packages match, so we can reshuffle it, rearrange it as 3x plus 1 times x minus 7, just like that. Right? It's the same factorization that we did initially using guess and check. All right, next one, just to practice it one more time, I'm just going to do this guess and check. So if you like grouping, you can practice that too. So here I see that I have 2x squared plus 5x minus 12. Open parentheses. Has to be 2x and x in those first two positions. Now 12 could be 1 and 12, could be 2 and 6, could be 3 and 4. Now again, one has to be positive and one has to be negative. Now I can eliminate this option right away. Can't be 2 and 6 because they're both even. And the reason that that actually wouldn't work, both even, is because if they're both even, I'd have to have an even number next to that 2x, and that means I would have had a GCF, which I do not have. So that option's out. That also tells me that I wouldn't have the 12 here or the 4 here. So it would have to be a 1 here, 12 here, 3 here, 4 here for my options. Again, 1 negative, 1 positive. So if the 1 was here and the 12 was here, I'd have a 24x plus 1x. Even if one of those is negative, not going to give me 5x in the middle. So it must be the 3 and the 4 that have to go here and here. Again, if the 4 was right here, I would have had a GCF of 2 to divide out first, and I don't. So now, what is going to get me that 5x in the middle? So this is 8x, this is 3x. So it must be a plus here, a plus 8x, and then a minus 3x that gets me that 5x in the middle. So perfectly factored using that guess and check method. You're welcome to practice using the grouping method as well. Okay, last skill for the day is looking at perfect square trinomials. So that is this structure that we're seeing right here. X squared plus 2xy plus y squared. That factors into x plus y times itself. So we just say x plus y as a quantity squared. Or x squared minus 2xy plus y squared equals x minus y times itself, but we say x minus y is a quantity squared. So the way that we can recognize that is that the first term is a perfect square. So is the last term, perfect square. And if I take the x times 5 and I double it, it gets me what's in the middle, right? Here's negative 10x. I see 10x. So I know that that just means that what joins these two terms must be a negative. So it must be x minus 5 times x minus 5. So think about when you FOIL it, the outer is minus 5x, the inner is also minus 5x, right? You have two of them. That's how we're getting that negative 10x in the middle. We want you to write this as x minus 5 as a quantity square. Okay, last variation. Again, first term, last term are perfect squares, right? This is 4x as a quantity squared and 3 as a quantity squared. And if I take that 4x times 3 and I double it, 4x times 3 is 12x times 2, that's 24x. And it is a plus in the middle. So that means there's going to be a plus that joins those two terms. So 4x plus 3 times 4x plus 3. Again, if I check that, the outer is 12x, the inner is also 12x. So it makes sense that I have 24x in the middle. We want you to write this as 4x plus 3 as a quantity square. All right, have a good rest of your day.